Okay, so while you are settling down, don't take out anything from the bag. Then you don't feel the. Okay?
No, I'm fine.
Okay.
Let's do this.
Okay, good.
In a week.
Okay, good. So you don't have to actually. You have everything uploaded. Okay. So
Actually,
yes.
I didn't even do anything.
Yeah, I can tell.
I mean, I shouldn't even take this as doing something. I only did one question.
Yeah. Okay, good that you admit it upfront. Yeah. Yeah.
Uh-huh.
Very appreciate your candor. Okay. But anyway, let's start off with the question two. Actually, question two is the question is very relevant to the question you asked me. Okay, over WhatsApp.
Oh
Okay,
yeah.
yeah.
So they started doing logarithm. I
Mm.
just started. So I just like revised logarithm again with all the video you showed.
Yep. And then
And then I think I kind of know all the basics now.
Yeah.
I memorized all the
rules.
rules.
Yep. So you have to get the rules. Yep. You have to get the rules.
Yeah. So basically, they use logarithm to find the unknown power sometimes.
Yes.
Most of the
Yes.
times.
So in fact, okay. Let me just pick up from where you just left off. So you were saying, so you get your 2 to the power of x is equal to, let's say,
Log
5,
two.
right? So in fact, we talk about this rule. What is the rule? The rule is you have the log, and then 2 is the base. 2 is the base.
Yeah.
Then 5 is here. Then x is
Exponential.
the other side. Okay, so that's how you can get the value of x. So after that, how do you get the value of x? X is equal to log 5 over log 2. So you just have to punch your calculator, log 5 over log 2, then you get the value of x. Okay, so this is, okay, we have talked about this already.
Yeah.
So we have talked about how you get from indices to logarithm. So you also need to know how to get from logarithm to indices. Meaning, like, if I give you indices, you need to get it into logarithm. If I give you the logarithm here, you need to get it into indices.
Okay.
And you understand?
Mm-hmm.
So you need to know how to get it from one to the other and then the other to the one. Okay, so let's start off with the question 2, because question 2 is related to the questions that you asked me yesterday. Okay, so start off with the 2b first. So 2b is, can see?
Yeah, yeah.
Okay, good. So 2b is, you have this. Okay, first thing first, you have to get things right, primary stuff. If you have 20, 2 times 2 to the power of 3, right? You don't do the 2 times 2 first.
Yeah, you add.
Okay, so you don't do like 4 to the power of 3. This is wrong. Why? Because when you have the cube and when you have the times, you do the cube first. Okay, but yesterday I look at that question. You have 4 times maybe 4 to the power of x, right? I see that you make that horrendous mistake, like 16 to the power of x. You didn't realize that? You need some evidence. Okay, good. Since you need it, then I have to. What's this? Okay. It's not your mistake.
No, it's not me.
Okay, so you have so you are Lakshan, so there is a monster inside you,
Yeah.
so that monster make that mistake.
I think I do that like.
I call the monster Larry. Okay, so Larry, stop making this mistake. Okay.
Okay.
Okay, good. So yes, so you have to get things right. Like when you have the power and we have the times, you do the power first. So never do the times first. So the priority of the operation you need to know. Okay. By the way, there are students, right? Until today, they still have problems with this.
Oh yeah. Why is this like no this table
Yep.
going
So you
down?
have to find the sweet spot. Okay.
Okay.
So there is something you need to find the sweet
Is
spot.
this like a study table?
Yeah, I think it's a study table. I don't know, but I find it quite cool. So just okay. Some of my other students experience it, so they are fine with it. So you have to find that sweet spot. Okay.
Okay.
Okay. So never mind. So okay. So for questions like this, right? Never make this mistake. -1 then times 5.
Oh yeah.
Okay.
Let's
So
start
it's the
first.
same thing. So it's the same thing. If I give you like 3 times 5 to the power of x, right? You don't give me 2 minus 15 to the power of x, because you have to do the power first. Okay. So Larry, stop making that mistake. Okay, next, let's go back to the question here. So for this question, right, so what you see is you see the 2 to you see this, right? You see this. So you have to decide. Okay, what I see is do you see a common base here?
Yeah, I see 3 and 2.
Common. So 3 and 2, no, they sound different to me. So 2 and 3, they are different, right? And they sound different already. So probably I should just, okay, this one is, okay, so probably I should just get this out, okay, and then continue. So this y minus 1 go to 2, the y minus 1 also go to 3. Okay, so this is what you see, right? So if you pursue this path, what you see is you will see that you have that you don't have a common base. What do I mean by that? You have a 2 as the base, and then you have 3 as the base. So there is no common base. So there is no common base. Maybe this is not the way to do.
Substitute the, like, because you got y minus 1, you can substitute the power of y minus 1.
So in a way, right, what I'm trying to tell you is if they don't have a common base, then this is not the strategy. Okay? So you need to go for the common base. If you have that, then you can let the let something equals to that, then you can continue. So I'm going to get your question out to here. Alright, so this is the one. Let me just get this. Okay, so for this one, I think you have a common base. Okay, why? You have this 4x to plus 1 plus 4 equals to 20 times 4x minus 1. So what I'm going to do is I'm going to get the 4x plus 1, I'm going to get it into this format. I'm going to get it into this format. So I think after this, I think you can see that there is a common base, which is base 4. Okay, so for this, then you can start to simplify before you go further. Okay, so the 20 here, the 4 here, so you just get rid of it, then you get 5, right? Okay, then the strategy here is to maybe you let a equals to 4 to the power x. So once you let a equals to 4 to the power x, then you get 4a plus 4 equals to 5a. So therefore, a is equal to 4. Does it make sense? So when a equals to 4, that means 4x is equal to 4, right?
Yeah.
So x is equal to 1, right? Yeah, so that's how you get the x equal to 1.
Yeah.
Okay, so for this question, right, if you see a common base, okay, common base plus, you see exactly the same thing, right? You just let a equals to that thing. Okay, so then next, come back to the question here. Okay, so like I said, right, you don't see a common base. Okay, so 2, 3. So maybe you don't want to play with the common base, but I think you can play with the common power.
Yes.
Okay, so the common power is, I think, is y. But before that, you need to do some manipulation. So that's the reason why you need to be very good with the integers laws. Okay, all the laws. So 2, and 3 to power 2y, right? So you get this. Okay, let me not skip so many steps. If not, you can't handle. Okay, just get the plus 1, the power down to 3 first. So for this, you can get to this. Okay. Can? So you times 6 throughout.
To get the...
Okay, so to get rid of the 6 here, so you get 12. Okay, so far so good.
Yeah.
And then over here, right, actually with the bracket or without a bracket, they are interchangeable. I mean, you can rearrange them without taking care of the brackets. Okay, because when you have like a times b times c, right, the bracket is
doesn't matter.
as good as non-existent. Yeah, does not matter. Okay, so therefore you just get the 3 out is 36. 3 2y is 6y, right? So you can see that they have a, okay, so even until this step, right, you don't have a common power, right? So you need to get the 2 to the 3 so that you get 9. Then now you have the common power. So when you have the common power, so basically, right, for indices, you either play with common power or common base. Okay, so therefore I think it's pretty easy. The y is the power.
Yeah.
Okay, then you can group this, right? Then from this, then it's back to the indices form. You get into the logarithm form, so you can simplify 3 2 3 3. Okay, good.
Wait, can you go back to I'm trying to.
No, I just 6 over 9, so 2 over 3 only.
You just simplify.
Yeah,
Okay.
so log base is 2 over 3. 36 is here. Y is the, yeah. So you just use your calculator and then get this.
Oh yeah.
Okay, so that's the value of y.
Log 10 36 or
Yeah.
log 10
Yeah. Yes. Okay.
Okay.
Good. Yeah, so basically, right, for indices, all you need to do is you either look for common base or common power. So in this case, it's common power, right? Because you try to do it with common base, right? You don't see a common base, right? You saw the what, base 2, the base 3, then there's no common base. Then you do the common power. Okay. Okay. Good. Then yeah, that's it. So I would like you to do 2A. See if you can still remember 2A.
Okay.
Yeah. Since you said you have done some revision, right? Last minute, yeah.
Yeah.
Yeah. So see if your last minute revision will help. 2A.
Okay.
Just do it somewhere on a blank page. Later, you just screenshot and then I will just airdrop to my Mac. Go to the Can you tell me what's your strategy to do this question? Still not yet.
Yeah.
Okay. No strategy.
Just go along with the flow.
So what I observe here is you have different base. So when you have different base, what you do?
No, try to make it like the whole number.
No, you have different base, log 4 and log 2 in this logarithm question. So what is the strategy?
Try to make it same base.
Yes, so that's your strategy. You should make it the same base first. Without making it the same base, so you want to play with log 4 or you want to play with log 2?
Log 2.
Yes, then you change the log 4 to log 4 to log 2 here.
Oh. Wait, I forgot how to do that.
Yeah.
check the notes.
I thought you say you remember the rules
yeah. Let
already.
me just check the notes.
Okay, yeah. You remember where to find the rules
Yeah.
instead of remember the rules. Okay, that's a nice one. Nice
I know,
one.
I know some of the
Okay.
rules.
Okay. Nice one. Which one you should pick? You change.
I feel like this one.
Yeah, because why?
Because you can change the
Yeah.
base.
You can change to log 22, then you can even change to LG, right?
Yeah.
Yeah, you should make use of this. Yeah. Yeah. How do you change the log 4 to this? The log 4 something term. The log 4 x term to log 2 something. Yeah. Yes. Oh yeah, so for logarithm or indices, right, you have to know the rules well. If not, you can't do it. Not you remember where to find it.
Okay.
Okay.
What's this log 2, 3? Where did the 3 come from? Or is that
Which one? Which one you talking about?
this one?
The log 2 3 is I give you another example
Oh,
instead of A B.
okay.
Okay, like I give you a concrete example. Yeah.
So this will equal to log 2x. Is this correct?
Okay, so in fact, right, so the strategy is change of base, change to the same base lah. So basically for logarithm, you just need to like find a common base, just like your indices just now. You either play with common base or common power for indices, but for logarithm is common base. Okay, so just to highlight to you this, okay, you can bring the 4 to the x to power 4. Okay, or you can choose not to do anything to the 4. So I really leave it to you. Okay, so I'm saying whether your 4 you want to bring it up to the power of the x, or you want to leave it here, up to you. So you want to bring it up or leave it?
Bring it up.
Okay, so you get log 4 x to the power 4 equal to 4 equal to log 2 x plus 5. Okay, so the next step, right, the next step for you is to change of base, because you see 4 and 2. Which one? 4 plus. Sorry, yeah, I have a double equal sign. Yeah. So by the way, you are not supposed to have double equal sign.
Yeah.
You don't show me a equal sign here also. There are students who show double equal sign.
So
Okay, no need. No need. One is enough. So you change your base. Use the change of base rule, which is log 2x over log 2 2. Okay.
log 2 2.
Yep. Log 2 4. I'm sorry. Yeah. So why? Because you have the x to the power 4 here, right?
Yeah.
And then you have the 4 here, right? So x to the power 4, and then you have a 4 here, right? Okay, good. So for this question, right, I think it's better you put the 4, just leave it. I'm going to show you why.
Okay.
Because once I get it into this format, I realize the 4 is better to be left untouched.
Okay.
So the 4 instead of here should be in front, right?
Mm.
Okay? So why? Later you will see.
Yeah. Later.
Because log 2 4, right, if you use your calculator, you get 2. So you have 4 here, you have 2 here, then you just
Oh,
you have
two.
2. Yeah.
Then just two log.
Yeah, exactly.
Ah, okay.
Okay? So that's the reason why I say it's better to leave the 4 here.
How are you able to see that?
Because I see there is a fraction. There is a fraction. The fraction is a whole number. So when you have a fraction, so if you have a fraction, right? I mean, it's better for you not to play with fraction.
Yeah.
So that's why if you bring the 4 up, right, the 4 cannot cancel the fraction or the denominator. Okay, so yes. Then after that, then I think the question is very easy already. Okay, what's your next step? Yeah.
My next step, take the log twos all and like group them together.
Okay, you can group them together, yes. But you can also do this thing. Okay, group them together is in a way like, let's say you have 2x equal to 5 plus 3x. So in a way you want to like group the x together, right?
Yeah.
So park all the x one side and then the non-x the other side, right? That's the one strategy. But I would like to approach this question from another perspective. So next time if you face this question, and then of course you can choose to do it this way, group together, or you can do it the other way. So the other way is this. I'll continue. I don't want to group them, so I will change the log 4 to log 2. I will change the whole number to log 2 something also. So it's 16.
Wait, how do you?
Because 2 to the power of 4. And log 2 to the power of 4, log 2 cancel each other, that's why you have 4.
Oh.
Okay? Then
So log 4 for example is always 1, like the
log 4.
yeah.
Then the power is 1, then it has to be 1. Yeah, why? Because you can bring down the 1 in front, right?
Yeah.
Then log 4 is actually
Just
1, yeah. Not 0, 1.
Yeah.
Okay? So the power here determine the value.
Okay.
Okay?
Right. Understand.
Then after that you have this x plus 5. Okay, good. So what you have here is pretty simple. You make use of the product rule, which is log 2 to the power of 4. Is it times? Can you help me check? Is it times? The product rule. Like you have something plus and then take these 2 out is times.
Yeah.
Okay?
Yeah.
Okay? Yeah. Then therefore here you get log 2 x to the power of 2. So in a way, right, you can actually get rid of this you can get rid of this log 2 and log 2. So basically you end up with a quadratic.
Oh.
Does it make sense?
Yeah.
This way of doing this question?
Yeah.
Instead of grouping the
So what if you group? Then
you can group. It's the same thing. But I just want to offer you another perspective.
Can you show me like when you group also?
Group, then you just bring it over, then you just bring this term over, then you use the product rule or division rule.
Then how do you take away the log? Oh, you do it by like putting it in a fraction form then.
You get the log, right? Later you get the log, something like this is 2, right? Then you get this into the indices form. A to the power of 2 equals to B. Yeah.
Okay.
Okay? So x2 is equal to 16. X. Okay, I will leave it to you. This is quadratic. Okay, so just okay. This quadratic might not be so easy to do factorization method. Then you use the calculator. Okay, so your a is 1, then this is minus 16, minus 80. You can use the formula also. Okay, so I'm not going to talk about this because I'm not going to talk about the quadratic part. So I just tell you the approach. Okay, so that's how you solve logarithm. So after question 2, the key idea for logarithm and indices is you either make the same base, common base, or you play with common power. Common power works for indices.
Okay.
Okay, then of course you need to be so good with the logarithm rules also.
Okay.
Okay, yeah. Okay, next. Okay, for the partial fraction, I don't think the partial fraction
You don't need to
I don't need to talk about it because I look at your this working, it looks
Should be
good.
fine.
Yeah, it looks good. And in fact, right, actually partial fraction is the giveaway. Why I say so? Once you get the partial fraction, right, you can try to merge this partial fraction back to the common, like a common fraction, a single fraction. If you can get back the single fraction, that means you're right. You understand what I'm talking about? You understand what I'm talking about?
Nope. No.
Okay. So this is partial fraction. You split to half and minus the 1/3.
Yeah.
And then you make it back to the make it back to common. Yeah. So it's okay. So basically, right, partial fraction is like I give you a single fraction, you need to help me get it into this minus this. This from single fraction, right, to split is called partial fraction. So what I'm trying to tell you is, I give you a single fraction. If you split to this partial fraction and your answer is this, right? Then when you get this, then how do you know whether your partial fraction is correct or not?
Add them up together.
Yes. Then combine it back to a single fraction. If you can get back the original single fraction, that means you are right. If you cannot get back, wrong lah. Simple as that, right?
Yes.
Yes. Okay.
Okay.
Do you learn any mathematics in India?
No.
No. Okay. I thought you get some guru training from there also.
Oh no.
Okay.
No.
Okay.
No, I was never studied during my
Okay.
vacation.
Okay. I thought maths comes from there, right? I don't know. They say some
Yeah, a few
Yeah.
of it actually like a lot of it came from there, but not all.
yeah. They talk about some Indian students, their mathematics are very good. Maybe that certain a few only.
Mm.
Yeah. Not all not all.
Yeah.
We can't generalize. Okay.
Cannot.
Okay. Okay. Good. And okay, among all the questions here, which one you want to talk about?
You know what? I actually don't really know. I had another plan come
Okay.
today.
Good. Okay.
So,
Mm.
basically, my teacher gave me lots of logarithm questions.
And you don't know how to do it.
Yeah, I need help.
Yeah.
So I thought we could do
Okay.
it together.
Yeah. Okay.
Yeah.
Mm.
Okay.
And
Also,
by the way, logarithm, I thought, right, your school taught you like term 2. No, not at all.
no.
Then how
Just
come we move on to coordinate geometry already?
No, coordinate geometry was for my E-maths. That's all.
Yeah, this is A math.
Wait, I don't understand. Like, why?
Your coordinate geometry is from your E math.
Yeah.
No, we are talking about A math coordinate geometry.
Oh.
Yeah.
E-maths. We never learned coordinate geometry.
Have. No. Your school might not teach you the A math coordinate geometry, but we have moved on to coordinate geometry already.
Yeah.
So logarithm and indices should be like so far behind us already. That's my point. We can take a look on that. 11, yeah.
Oh.
Actually, we talk about coordinate geometries like in our homework 10 already. Yeah. So if you look at this, right, this what indices and logarithm, right, was way back, like.
Yeah, we started a long time ago.
Yes. Okay. But actually, we can do logarithm and indices, but I don't want to spend too much time. Okay.
Okay.
Give me like, okay, maximum two logarithm.
Okay, then I choose the hardest question.
Yes. Continue.
Let it no. So okay, let's see.
You can show me the textbook one.
Yeah.
I'm
so I
okay
can
with
see.
textbook.
So
Mm-hmm.
5 by 3.
Mm.
Oh, found it. 14A.
Let me see. Okay, this kind of question. Okay. So with this, you need to be very good with the logarithm rules. Yeah. Actually, without you knowing all the rules very well, right, there's no point talking about logarithm. Because my experience with student is when I do here, that means when I guide them, it's like, oh yeah, but I leave them alone. Don't know.
Yeah, that's true. That's same for me.
So okay, the main difference between you and me is I know the rules very well,
Yeah.
but you don't.
Yes.
So in order for you to reach close to my level, then you need to know the rules first. Okay, that means you need to know, like, let's say you stay in Lakeside. Okay, I also know Lakeside very well.
Yeah.
So we need to both have knowledge about Lakeside, then we can talk things out
Yeah.
smoothly, right? So if I talk about Chinatown and then you don't know anything about Chinatown, the discussion won't be smooth. Yeah, you understand? So you need to form the basic knowledge first. Okay.
Okay.
Yeah. And by the way, we talk about this like logarithm like few weeks back already, so I expect you to know the rules by now. Okay, so it says given this, and then of course you need to show this, right? Okay, so
Okay.
for this one, then you just have to write out what is 2a lor. Can you continue? Can you write out what's 2a? Like you also do it. Just why you pick this one, by the way?
It's the last question.
Oh, okay, like advanced question, maybe advanced question. Can you write down 2a in terms of logarithm?
You just write down the question.
Yeah. No need to write down, just continue from this. Like 2a is 2 log 4y lah. And you know these days Singapore have another wave of COVID cases.
Really?
Yes, like 10,000 plus.
Wow.
Yeah. Even when I think 1 out of 4 of us, okay, is infected with COVID once. Okay.
Well, I've never been. Actually, I was sick. Actually.
Okay.
I still am.
Not COVID.
Not COVID. Yeah.
Or you refuse to take the ART.
No, I took it 2 times.
Oh, okay.
Yeah. It's my first time actually take ART.
And you know they say, right, the ART you need to wait for at least half an hour before the result come. I mean before the second line come. You know a lot of people, right, they just take it, right, then after 5 minutes, yeah, 1 line, then throw away the test kit. You are supposed to wait like 20 minutes for the second line to come up.
Well.
Yeah.
Yeah.
I doubt you wait for 20 minutes.
Yeah.
Maybe 5
No,
minutes.
but I took in the clinic though, so
Oh,
I'm pretty
okay,
sure they
okay.
would have done a
Okay.
good job.
Clinic, okay, good.
Yeah.
Okay,
Clinic.
okay,
Trust clinic.
okay. So drink more water lah, yeah.
Yeah. I'm not coughing.
Water, yeah. Drink more water, not the sweet stuff, yeah.
I don't really like sweet milk.
Oh yeah, okay.
Are you drinking tea?
Yeah, good. Yes. Iced tea.
So, what are we? Is this like simultaneous equation?
So you just get it into this one. Right? And you just have to prove this. They are valid.
3D. Oh.
Okay? You just have to prove this, they are valid.
Okay.
Change of base. Right?
Yeah.
Yeah. 4 and 8, then you just pick the. Actually, between 4 and 8, right, I suggest you still go back to the lowest.
Yeah. 4.
Actually, between 4 and 8 is not 4. I mean, yeah, between 4 and 8 is 4. But I think you should change to the lowest base, which is log 2.
Okay.
Yeah. The thing is, yeah, so next time when you see 4 and 8, yeah, the you should pick log 4, right? But actually you should pick the lowest. Log 2, yeah. So they have both log 2. I will tell you why later. Maybe later you will realize why choose log 2 instead of log 4. May. Yeah. Can I look at the first step first? Oh, no need. I think just yeah, good. Let me just move. Actually, the 2, right, is good to be in front instead of you bring it up. Why? Because you can, yeah, there is a fraction, right? Can you see log 2 4? You can use your calculator, is 2. So there is a fraction. I mean, there is a denominator. So when you have a denominator, so don't bring the 2 up.
Okay.
Yeah. So we talk about that, right?
Yeah. So it actually be
Let's get
2
rid of
and
it.
2.
Yeah.
So it just.
There you have the erase. Yeah, yes, correct. Yes. And then for the log 2 to it, I think you get a value also.
Really.
So the 3, I think you can bring down also.
Oh yeah. This equal to 3 actually.
Below is 3.
Below is also 3.
No, why that one is 3? Can you not erase the numerator? I say your 3, you should bring it down.
Oh.
So it means you don't bring the, so basically you still retain the 2y. Retain the 2y. That means don't convert. Yes. So remember the 3, you bring it up only when necessary, but in this case you can get rid of the denominator, which is log 2 8 is equal to
3.
yes. So minus 1. Yeah.
So now we show that 2a. Okay.
So I think we did this question just now. I have a whole number. Just now the whole number is 4, right? The previous question. The whole number is 4, right? I get it into log 2 something also. So the 1 you get it into log 2 something also. Minus log 2. So you need to get 1. So 2 to the power 1.
2. Oh yeah.
Yeah.
2.
2 to the power 1. Yeah. Okay. So yeah, continue. I think over here minus use the product. Use the division rule.
Division rule.
Yeah. You want to refer to the division rule? There is a product rule. There is a division rule.
Oh yeah.
Yeah. Yes.
So it is
2y over 2.
so it's actually y.
So shown. Shown. Yeah. Left hand side equal to right hand side. So shown.
But isn't it already same?
Yeah. So same. That means shown. You already proved the you have to prove that this side is equal to this side, ma. So you prove already. You are doing the proving now. Yeah. Shown. Right?
Yeah.
Yeah. Because 2a equals to 3b minus 1, it does not look the same. Right? So but after substituting all this into the a and the b, right? Then you manage to show that the left hand side is equal to right hand side. So then show lah. Yeah. Understand?
Yeah.
Yeah. Okay. So that's it. So in fact this question is very similar to the question we did just now, but in another format lah. This question is asked in another format. Right? Okay. Good. So yeah, that's it. So I don't want to do B also. B is kind of like similar.
I see what else.
Yeah.
There's one more, right?
Yeah. One more.
What?
Actually, I will say logarithm questions is all about questions like this one, this one,
Yeah.
and just now that one. I mean, they can't test you more than this.
Oh. let's try another chapter.
Another chapter of? You mean revision of the previous chapters?
5.2, 5.3, so I think
Okay.
it's same.
Okay.
Let's try 5.2, 12. Which
Right.
one 12? I think it's
12. Okay, so this question, right? So now is logarithm or indices. So now they want to do some practical applications.
like real life.
Real life, yes. So so they say the population is governed by this formula. Okay, so the population of a species is governed by this formula. Okay, so this P is the population of that species. Then T is the time lah, the time.
Okay.
So this time is in months. Okay.
Okay.
So meaning what you do, okay, so just give you a very brief example. So let's say if after 1 month, right,
Yep.
is this right? Can you tell me what's the population after 1 month? Use your calculator. So this is after 1 month.
Two plus E.
Yeah. E is exponential.
Yeah.
You know how to key it?
Is it the
You
ln or
yeah, you need to shift the ln to get the E.
is it
No, you need to key in E. Where do you see the E?
oh, it's here. It's alpha E here.
Okay, good. Where is the E? I also want to see.
Here. On top.
I think this is the E. Because can you see E to the power?
Oh.
I don't want this E. This is the letter E, but this is the exponential E with the power. You need to key in power, right?
Yeah.
Yeah. So you need to pick that one,
0.2.
not that one. Okay. Yeah. So that one is the letter E, which I don't think you need to use. Minus 0.2 by the way. Minus 0.2. So what's the population like? Just
1,691.
okay. Let's make it easy. 1,600 lah.
69.
Okay, good. Just
okay.
roughly like this. Okay.
Okay.
So after 2 months, so you do the same thing lah. Just change to 0.2 times 2 ah. Can you just give me?
Now 1,602.
Also 1,602. So this one is 90 something, right?
Yeah.
Okay, good. Okay, just okay. I'm not too too concerned about the numbers, but I just want to show you what's the trend. Okay, let's say P to power 5 months.
It will decrease more.
I don't know. Let's see.
It is 1,420.
Okay, good. Okay, so what you observe here is, so basically they can ask you for what, 1 month, 2 months, or 3 months, or even 1 year. 1 year is 12 months, right?
Yeah.
So what you see is, you see the population actually decreasing, huh? Okay, exponentially. Okay, so generally what the question will be like is, actually they also would like to ask what's the population at the start. You know what's the meaning of at the start? Time what? At the start
0.
means yes. Can you try it out? What's P0? So I call it P0.
It's 0.
So can you tell me what's the population?
1,800.
No, wait, you calculate.
Yeah.
Oh, so fast?
It's just 0.
Oh, okay, good. Wow, so fast. Okay, good. I'm surprised. I thought you do it by mental. Okay, good. So 1800.
Yeah.
Okay,
Yeah.
good.
Mental max.
Actually, you can do it mental. You know why?
600 times 2.
No.
Oh, wait.
This is e to power of 0, right? You know e to power of 0 is 1. Like anything to power of 0 is 1.
Yeah.
So therefore 2 plus 1 is 3. So 3 times 600 is 1,008. I mean 1800, yeah.
Yes.
1,800, yeah. Okay?
Mental max.
Okay, good. So generally what they like to ask is at the start population. And then after the start, right, then in this case it will start to decline. So generally they would like to ask after
5 months.
a long time.
They will.
You know what's the meaning of long time?
No.
Like t equals to like maybe a million years, or let's say it's like
X.
I would say infinity.
Okay.
So what will happen to the population infinity?
0.
Why?
Because it keep
How do you
decreasing
okay, you can say okay it's 0, but how do you justify it's 0?
by showing like 3
Yep.
after
So in fact that is one way, like you want to show that okay the population actually they are decreasing
every month.
exponentially, right? But how do you justify p infinity is 0? You use this method. For this case not every case
Okay.
you don't like oh every time is decreasing. You know certain things go up okay? It's just like COVID cases. Yeah. Okay, so how you do this is your p infinity means 600 2 plus e, so your this 0.2 times infinity, right?
Yeah.
So 600 2 plus e minus infinity, right? Because 0.2 times infinity is infinity, right? Then you need to get this negative index. This is called negative index or negative power. So you need to get it into positive power. Okay, so e to the power of this infinity, right? Do you know that this thing is going to be very very,
High number.
this one is very very big, right?
Yeah.
So if this goes so big, right, 1 over so big means this is as good as
Infinity.
0.
Oh.
1 over big so 1 over big is this will become close to 0, right?
Yeah.
Am I right?
Yeah.
Am I right? Then if this close to 0, then 2 plus 0 is 2. Then the p infinity is 1200 leh, not 0.
No.
Okay.
I refuse to believe.
So if you are a forecaster, no, you have a very bad forecast. It's not 0. Okay? The ultimate value for this population of that species is 1200.
Okay.
Okay?
I understand.
So first thing first, do you understand that why this is e to the power of negative infinity is going to be 1 over very big?
Yeah.
So 1 over very big means, because you try 1 over 1 million is like 0.0, that's very close to 0, right? That's why I say close to 0. So 2 plus close to 0 is 2 right? So therefore 2 times, that's why I say p infinity is this. So you cannot look at the trend. So what I'm telling you is, if today's COVID is 1,000, then tomorrow is 900, the day after is 800, you don't tell me the next day is going to be lower than 800. It might not be. It might not be. Okay? So this is also something we need to learn it for in real life. It's like generally we human nature is we see pattern in everything. Seriously, we see pattern in everything. That's how we organize our life. Do you know that? Do you know this fact? Like we see pattern in everything. You but I don't think you know what I mean. Even though you okay, yeah. So basically, in real life, we are human nature is we tend to see pattern in everything, but this is not a good thing. Okay, it's not a good thing. Okay, because sometimes the trend might not follow the past behavior, and that is where you will get into trouble if you think the trend will continue. Okay? If you don't remember anything from my mathematics class, please remember this. Okay? Okay? The trend might not continue.
Okay.
Okay? Can? Okay, good. So yes, so the P infinity is so basically the population of the species will somehow stay around 1200.
Okay.
Okay, can? For this question okay, of course the these different equations is different numbers already. Okay? Sometimes the population can go zero, but this is not the case. Then another way to look at this is of course get it into graph to see whether it stabilizes at 1200. We have a very good tool,
GeoGebra.
right? GeoGebra, right? Yeah. So just get it in. Y equal then 600
600 times
then 2 plus e to the power of negative
point
0.2 x.
infinity
X, right?
into x. Then it knows is
Oh,
infinity.
how do I get times is not this, times is this. Eh? Nothing why there's nothing? Is it because how come this one doesn't work today? Do you have the app?
Sure.
Yeah, please try your app. How come?
I have on my iPad.
Yeah, please do it.
It has the GeoGebra. There it is.
It's very funny.
So 600.
Yeah.
What is it? 2 plus e.
Yeah.
E to the power of
Oh, maybe my E, I cannot key in E like this. Maybe I should use their E.
negative 0.2x.
Yeah, I need to use their E. No, doesn't work. Okay.
Okay.
Can? Do you get the graph?
Is it this one?
Yeah.
Nope.
Nope. Okay, good. So, yep. So,
It's good
good means no, this is my catchphrase, right? It's like, yeah, whatever it is, I will say good. You know that, right?
Yeah.
Okay, now I get it from this Google already.
Wow. Google can do it.
Okay, so maybe I should use the Desmos. Desmos is another website that you can do a graph.
This is like just like GeoGebra.
Yes, exactly. But I need to.
That is suspicious.
8 times. This is minus 0.2
X.
x. It says
Error.
there is an error. Let me see. I don't understand the E.
Sure. Wow. Still way down.
Maybe they.
This has the exact same keyboard as
Yeah.
or something is very wrong.
Okay. You need to use this one. They call it this.
Or
Let me see.
AXP.
Still got error. I don't understand the way that these two comma. Oh. Okay, never mind. I give up. Okay, never mind. So I will figure it out on my own then. Okay, but yeah, that's the way.
Okay.
Okay. So yeah, we can take a brief break.